In the previous discussion, we were able to find the values of the 6 trigonometric functions in the rectangular coordinate system, regardless whether the terminal side of the angle is in the first quadrant or the second quadrant or the third quadrant and the fourth quadrant. The important thing to do in order to apply the definition of the trig functions is by creating a right triangle. In our images, in the first quadrant, the right triangle is produced between the x-axis, the positive x-axis, and the terminal side of the angle. Now in the second quadrant, the right triangle is produced between the negative x-axis and the terminal side of the angle. And in the third quadrant, it is produced between the negative x-axis and the terminal side of the angle. And also for the fourth quadrant, the right triangle is produced between the positive x-axis and the terminal side of the angle. Okay, although our theta here, these angles, the theta is actually explaining about these angles, this one, these angles, this one, and this one. However, in the second, the third, and the fourth quadrant, we created another angle because it is necessary to apply this concept on the right triangle, because that's what we have defined. We defined the 6 trig functions on the acute angle in the right triangle. Now, the creation of these triangles here are very important, and these triangles are actually called reference triangles. So what are reference triangles? So this is our definition. To form a reference triangle for an angle, draw a perpendicular line from a point P on the terminal side of theta to the horizontal axis. Example, in this image, our terminal side is in the fourth quadrant. So to form the reference triangle, we have to draw our perpendicular line. So this is our perpendicular line here, the imaginary. Okay, we have to produce the perpendicular line in order to form a right triangle so that we can apply the 6 trig functions. Okay, so what is a reference angle? The reference angle alpha, let's denote this one as alpha, is the positive acute angle between the terminal side of theta and the horizontal axis. So this is our reference angle. Take note that our angle here is this theta. Okay, so the rotation is counterclockwise from the positive x-axis to the terminal side of this angle. Okay, and our reference angle is the acute angle produced by the terminal side of the angle and the x-axis. So now, how to find or solve the reference angle of the given angle? So we have 4 cases. So for the first case, if theta is a quadrant 1 angle, then alpha equals theta. So the angle and its reference angle are the same. Next, for the second one, if theta is a quadrant 2 angle, then our alpha is 180 degrees minus theta. So in this case, this is our reference angle and this is our reference triangle. And the reference angle is computed by 180 degrees minus theta, or pi minus theta. For the third case, if theta is a quadrant 3 angle, then alpha is computed by theta minus 180 degrees or theta minus pi. Now for the first case, if theta is a quadrant 4 angle, then alpha is computed by 360 degrees minus theta or 2 pi minus theta. Example, find the reference angle alpha associated with theta equals 120 degrees. So 120 degrees, if we are going to locate this one in the rectangular coordinate system, this is a second quadrant angle. So this is 120 degrees. Now, again, if the theta is a quadrant 2 angle, we compute the reference angle as 180 degrees minus theta or pi minus theta. So therefore, to solve for the reference angle, this is 180 degrees minus 120 degrees, which is 60 degrees. So this is our reference angle. So next, we have an exercise set. Try to solve this exercise set on your own. Take note also, guys, that the theta that we are referring here, this one, this one, this one, and this one is already the smallest positive coterminal angle of the given angle. Example, if let's say beta is our given angle, 500 degrees. Where do we find the 500 degrees in the rectangular coordinate system? Take note that the one rotation is 360 degrees and our angle here is 500 degrees. So you can add that rotation, and that's somewhere in the second quadrant. Okay, this is 500 degrees. And what is the smallest positive coterminal angle? Is this one. Let's use another color. Okay, this one is the smallest positive coterminal angle of 500 degrees, and this is our theta that we are referring in these four cases. This one, this one, this one, and yeah, the first quadrant. Okay, so how do we compute that theta there? It's 500 degrees minus n times 360 degrees. The n here is the number of rotations before reaching the terminal side of the given angle. In this case, our n is 1 because the two rotations is 720 and so on and so forth. So multiples of 360. So our theta here is 500 minus 360 degrees, which is 140 degrees. So this is 140 degrees. Okay, so for the reference angle, we compute the reference angle here as, since it is in the second quadrant, this is 180 degrees minus 140 degrees. Okay, which is 40 degrees. It is not 180 degrees minus 500 degrees. Okay, although 500 degrees is our given angle, we use this theta here, which is the smallest positive coterminal angle of 500 or of the given angle. So in our exercise set, you can encounter that one. This one here is greater than 360 degrees, and maybe some of the problems that you will encounter will be greater than 360 degrees or will be greater than 2 pi. So first, find the smallest positive coterminal angle before solving for the reference angle.